Let us see one problem on cyclic encoder. Here it is asked to draw the encoder for cyclic code having generated polynomial x raised to 4 plus x square plus x plus 1, and we have to obtain the code for the message 110. So we have already seen two problems on encoder diagram. So let us revise that. So for drawing the encoder, we need the generator polynomial. So here the generator polynomial is x raised to 4 plus x square plus x plus 1. Now the code is so how can we find the code n? What is the value of n? So message is 3 bits, that means k equal to 3, and degree of the generator polynomial is 4. So n is equal to, so this degree is n minus k equal to 4. So n minus 3 equal to 4. So n equal to 7. So this is 7 comma 3 code. So degree is 4. So we have already seen how to draw this diagram. So if degree is 4, then number of flip-flops required are 4. 1, 2, 3, 4. Now this is the same as we have seen in the previous two problems. So here the message is coming. This is a switch which we can connect to pole 1 as well as pole 2, and there is a feedback switch. So if there are if the degree is 4, then you have to draw flip-flop 0, 1, 2 and 3. Now this line corresponds to coefficient of x raised to 4. Coefficient of x raised to 4. So that is equal to 1. That's why this line appears. Now x3 is not there. X raised to 3 is not there, or its coefficient is 0. So this in between line is not there. Coefficient of x3. Coefficient of x square is 1. That's why this adder and this line appears. Now coefficient of x is there, so coefficient of x is 1. Coefficient, whenever coefficient is 1, then that line appears, so this line appears, and 1 is always there, so coefficient of x raised to 0 is equal to 1. So this line and this line is always there, this and this line. This line corresponds to coefficient of highest power. Coefficients can be either 1 or 0. So we have already seen that first the message enters into the circuit. At that time this switch is connected to this pole. Then message will appear at the output, as well as it will go inside the circuit. At that time feedback switch is closed. After entering the message, that is, what is the message? 110. After entering those 3 bits at the output as well as into the circuit, feedback switch is open. Now during that time the parity bits are generated. After feedback switch is open, then those parity bits will get collected at the output. At that time this switch is connected to pole 1. So this is the simple explanation of this circuit. Now the same is drawn here because we have to explain this. So so instead of turning the pages, I have drawn it once again here. So the same diagram. So in the exam there is no need to write here coefficient of x raised to 4, coefficient of x square. This I have written here to understand you how these lines are drawn, how these lines appears. If the coefficient is 1 of that particular power, then only that line appears. So no need to write this one in the exam. So this is the diagram which is already we have seen. So this portion, as this portion you by heart, this feedback switch also, so that will become easier to draw the circuit. Now let us see the equations. So you can observe here that flip-flop 0 input, flip-flop 0 input is this one, this one. This is coming to flip-flop 0 input. So what is that? That is D, that is message, plus flip-flop 3 output. So same is written here. Now flip-flop 1 input is this line. Now this line is nothing but D plus flip-flop 3 output, which is nothing but flip-flop 0 input. So this line is nothing but flip-flop 0 input, because same is going to the flip-flop 0 input. So we can write it as flip-flop 0 input plus flip-flop 0 output is the flip-flop 1 input. So flip-flop 1 input is flip-flop 0 input. So flip-flop 0 input, because same is coming here, as well as flip-flop 0 output. Now what is flip-flop 2 input? That is, this line is flip-flop 0 input, because same is going to the input of the flip-flop 0. So flip-flop 0 input plus flip-flop 1 output. Now what is flip-flop 3 input? Flip-flop 3 input is flip-flop 2 output. Flip-flop 3 input is flip-flop 2 output. After that, now we have to build this table. For that, you remember, you just assume that input is nothing but the present row, because we have to use this, these equations. That's why input is present row and output is previous row. Input is present row and output is previous row. So D is written, that is message, then flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3. So firstly, when there is no input, initial conditions are 0, 0, 0, 0. Now flip-flop 0 input, now flip-flop 0 input, this input means present row, this you are calculating is the input. So these equations you have to use. So flip-flop 0 input, this one is equal to D plus flip-flop 3 output, means previous row. So D plus flip-flop 3 output. So 1 plus 0, that is equal to 1. We have written it here, flip-flop 0 input. Now what is flip-flop 1 input? That is this one is nothing but flip-flop 0 input and flip-flop 0 output. Flip-flop 0 input is present row 1 plus flip-flop 0 output means this row 0. So 1 plus 0 is 1. Now what is flip-flop 2 input? This you have to calculate. So flip-flop 2 input is equal to flip-flop 0 input, this one, plus flip-flop 1 output, this one. So this 1 plus 0, that is equal to 1 is written here. Then after that, what is flip-flop 3 input? Flip-flop 3 input is flip-flop 2 output. So this one. Output means previous row. This is directly taken. So for calculating this row, you have to take so flip-flop 0 input, that means flip-flop 0 present row is equal to flip-flop 3 output 0 plus 1, that is 1. Flip-flop 1 present or row or input is equal to flip-flop 0 output plus flip-flop 0 input. So 0 plus 1 is 1. Flip-flop 2 input or present row is equal to flip-flop 1 output or previous row plus flip-flop 0 input or present row. So 1 plus 0 is 1. Flip-flop 3 input is flip-flop 2 output, so or previous row. Now once you understand these operations, the next row calculation is very easy. So next D is D is 110. So write down 110. So 1 plus 0 is 1. Then because we have already understood what are the operations, so to compute this element, you have to do this plus this 0 plus 1 1. To compute this one, you have to do 1 plus 1 0. How these operations are there? With these equations we obtain those operations. So 1 plus 1 0. After that, to obtain this one, you have to do this plus this 1 plus 1 0. This one is, you have to take it 1 here. Now it's easy. So this 1 plus 0 1, 1 plus 1 0, 1 plus 0 1. This 0 you have to take here. Code word is, input is 110 data. After that, you have to write code word like 0 from flip flop 3, 0 1 0 1, 0 1 0 1. Why like this? Because firstly, flip flop 3 output will come to the uh, output side. Then after that, flip flop 2, then flip flop 1, then flip flop 0. So let us do one practice. So with this same encoder. Now D is 101. This 101. So firstly, data is not there. So initial condition is 4 times 0. Now you know that 0 plus 1 1, 1 plus 0 1, 1 plus 0 1. This 0 will appear here. Then this 0 plus 0 0, 0 plus 1 1, 1 plus 0 1. This one will appear here. Then 1 plus 1 0, 0 plus 0 this 0, this 0 plus 1 this one, and this one will appear here. So code word then is this 101 data 101. After that 1 1 0 0. Don't write this D. You have to write flip flop output as the parity bits. This 1100 are parity bits 1100, and data is 101. Once again, this data first you have to write 101. After that, you have to write only flip flop output 1100. By mistake, don't write this one. And this is 7 bit only, na? So these are 7 bits 1 2 3 4 5 6 7, and this is systematic code. So message is appearing first. After that, there are these 4 parity bits.